Welcome. So today what we're going to do is look at how to write an equation that will graph a circle on an xy plane. So to do this, we're going to use the fact that the radius of the circle tells you the distance of any point on the circle from the center of the circle, and the fact that the radius is constant for every point going around the circle. So if you notice right here, what we're going to do is take the distance formula. We're going to substitute the x1 and the y1 with the center because that point is fixed. We're going to change d into r because instead of distance, we're just going to call it radius. And then we're just going to square both sides so that everything looks a little bit nicer, a little bit cleaner. So our formula is x minus h squared plus y minus k squared equals to r squared, where h and k are the fixed center, and r is the length of the radius. So in order to write the equation, we need to know where the center is, we need to know how long the radius is, and literally we're just going to plug it in to that equation. Right, so notice this is going to look an awful lot like the distance formula, but also Pythagorean theorem. Right, so x minus h squared plus y minus k squared equals r squared. Right, we get a plus 8 instead of a minus 8 because if I subtract a negative, it makes it positive. So if we simplify as much as we can, we get x minus 1 squared plus y plus 8 squared equals to 49. So for part B, I'm going to do the same thing, but instead of being given the information, I need to read it off of the graph. So I notice the point 0, 4 is at the middle of the circle, so I can use that for my h and k. And then I notice that the point 0, 7 is on the circle. So if I look at that, that's 3 spaces away from the center. So that means my r is going to be 3. So all we have to do now is plug in to the distance formula. So x minus 0 squared plus y minus 4 squared equals 3 squared. And then we simplify. Alright, so for this next example, I notice I'm given the center, but not the radius. So I'm going to start by just plugging in what I have. So if h is a negative 2, that's going to be x plus 2 squared. K is 4, so that's my y minus 4 squared, and I don't yet know the radius, so I'm going to leave it as r squared. I said the radius is the distance between the middle of the circle and a point on the circle. So since we know that the circle has to pass through negative 6, 7, if I can find the distance between those 2 points, that will tell me what the radius is supposed to be. So all I have to do is plug in to the equation that I've got so far, and we'll notice that r squared now is the only missing variable. So if we can figure out what r squared is, that's the missing piece to filling out the equation. So if I take negative 6 plus 2 squared, gives me 9. 7 minus 4 squared will give me 3. All right, add that up. Gives me 25. And like I said, our goal is to write the equation of the circle, not actually solve for the radius. So I know that if I wanted r, I could take the square root there but I don't actually care what r is, because in order to write the equation, I only need r squared. All right, so this next one is going to be a little bit more complicated. It's asking me to identify the center and radius from this equation. It also asks for the graph, but I'm going to skip over that for now and look at how to graph circles in our next example. So notice it needs to fit the distance formula, but at this point it doesn't. Right? There's too many x's and y's, and the constant on the other side is a -8, which doesn't really work for us. So what we're going to want to do is use a process called completing the square, so that I can take what I have and factor it to match the formula that I want. So the first step to this is going to be to rearrange the equation so that the x's and y's are grouped together. And if you had any extra constants on the left side of the equation, we would want to subtract them over to the opposite side so that we've got all the x's and y's on one side and all the numbers on the other. I also know that as it's written, it will not factor in the way that we want. So what we're going to need to do is add some extra numbers so that the factoring works out to make perfect squares, because we're going to need to factor it so that I've got two different sets of parentheses, and each one needs to be squared. We also know that we're technically allowed to do whatever we want to an equation as long as we do the same thing to the opposite side. So my whatever two numbers I add on the left, I also need to add on the right. All right, so we want this to factor to x minus something squared and y minus something squared, and we need to have just some number on the other side. So the trick is to remember that in a perfect square trinomial, in other words, if I want this to be x minus a number twice, the number that gets grouped with the x is half of the original term. So if this is an 8, this needs to be a 4. So whatever I put in that blank needs to go here. And since there's a squared on the outside of the parentheses, there needs to be a square on the 4. Of course, I know if it was x squared plus 8x, then when I factor it, it's going to be x plus 4 squared, so I need to make sure that those signs match as well. So for the y, 2y divided in half will give me 1y. And I noticed that I just copied that down wrong, so let me fix that real quick. This needs to be a plus. If I put a 1 squared in the blank at the bottom, I need to put 1 on top. And then similarly, whatever I put on the left side needs to go on the right side. So now we've sort of filled in all the spaces. We've already factored the left side, so we're good there. Now all we have to do is add up all the numbers on the right, and we've got it. So if we do that, we will get 9. So that tells us that our circle is centered. At 4 and -1. And since r squared equals 9, our radius is 3. Alright, so for the last example, we're going to look at graphing and finding the points of intersection between a circle and a line. So to graph the circle, we need to identify the center and the radius. Right, so since I don't see an h or a k, it means that they are both 0. So we're going to center it at the origin. The r squared is 4. So that means that the r is 2. So I'm going to go out 2 spaces from the center of the circle in all directions. And then connect the points to get a circle. And then I am going to draw the line y equals x, which has an intercept of 0 and a slope of 1. It's going to look like that. And we'll notice that there are 2 points of intersection here. So in order to find those coordinates, we're going to need to solve this like a system of equations. So we know that x squared plus y squared equals 4 and y equals x. So we can go ahead and substitute in to the first equation. And then we can solve it from here. So 2x squared equals to 4. X squared equals 2, which means that x is the square root of 2, and it can be positive or negative. And we can see that when we look at the points, because one is on the right side of the origin and the other is on the left. Because y is equal to x, we can go ahead and just say that y has the same values. And so now all we have to do is go back to our graph and figure out the exact coordinates of each spot. Right? So if I notice the point in the upper right corner, both the x and y should be positive. So that's one point of intersection. In the bottom corner, the x and y are both negative. So those are our 2 points of intersection. All right, that's all we have for today. I will see you guys next time.